web applications. So first, a bit about my company. We are an independent IT consulting organization. We are obviously mostly focused on OpenEdge and related technologies. Our main office is in Cologne, Germany, but we do have subsidiaries in the UK and Romania, which is where I'm based. Customers mostly in Europe, North America, Australia, and South Africa. And we are a vendor of developer tools and consulting services. We're specialized in GUI for .NET, Angular, which is my specialty, OO, software architecture, application integration, and experts in OpenEdge application modernization. Right, then a bit about this, a bit about what we can offer. The Smart Component Library, it is the developer framework for OpenEdge. It adopts the architecture best practices, OERA, CCS, OO, or ORM, DDD. It has user interface flexibility, so desktop, web, mobile, and mix. I'm actually the architect of the web and mobile clients for our framework. First-class RESTful services, rapid application development, migration tools that support harvesting of existing source code, and integration with existing applications and frameworks. And now a bit about myself. So I'm a consultant and developer. I have several years of experience with Angular, NativeScript, and Node.js. I am the I'm the developer and architect of the Smart Component Library framework for Angular and NativeScript. I do offer support to customers, consulting in web and mobile architecture, and I do provide trainings and mentoring services. Right, so first of all, what is Socket.io? Well, it enables real-time bidirectional communication between a client and the server. It is a wrapper around the WebSocket API. So very important distinction that Socket.io is not a WebSocket implementation. It is a library that facilitates working with WebSockets. It's a very important distinction there. How does it work? So the client first attempts to establish a WebSocket connection. Now, although most modern browsers today support WebSockets, some do not. And when that is not available, the nice thing about Socket.io is that it has a fallback. So it actually falls back to HTTP long polling. Does this automatically and on the fly. It supports automatically reconnecting when needed. So if a connection is dropped, it will reconnect when connectivity is available. Packets are buffered while not connected. So if your website goes offline for whatever reason, the user has lost internet connection or what have you, packets will be buffered, and when back online, they will all be sent. Although this does have the potential gotcha that if the delay between the loss of connection and reconnecting is particularly long, it could result in a huge spike of messages. So you could control this by checking if the WebSocket is connected or not before firing away a message. There are APIs for that. Typically, this is what a Socket.io enabled application would look like. So you have your various clients. Could be a desktop application, mobile application, web application, all connected to a Node.js backend that also has Socket.io installed and is using it. There are client SDKs available for JavaScript, TypeScript, Angular wrappers also, .NET, and many others. There are quite a few client implementations available. Right, but so now we could ask ourselves, why would we use WebSockets in the first place? That you could technically achieve most of the functionality with HTTP requests, but it is not really all that efficient, as we'll see in a bit. So having a two-way connection open between front-end and backend opens a lot of possibilities. So it allows the backend to push information to the front-end without the need of repeated HTTP requests. So think about the UI that needs a lot of updates rapidly with high frequency. Performing HTTP requests for all of this is not efficient and can cause delay because HTTP requests in the web are also asynchronous. You might run into bracing conditions between which request finishes first. They're not always going to finish in a linear fashion, and yeah, this could result in unpredictable behavior if there's a high frequency of updates. Now, the front end may also push new information to the backend relatively faster than through an HTTP request. That is also, again, helpful when a high frequency in updates is required. Use cases could be instant messaging applications, or let's say multiple users editing the same record. The record is saved by someone else. Other people that are viewing the same record might get a notification that this record has changed while they're actually still editing, and not spending time on filling in, I don't know, lots of fields and trying to save and then getting a validation error or something similar. Backend could be pushing notifications to connected clients, for example, schedule jobs that have started or finished successfully. You could be displaying process logs, so console outputs from backend processes. You could be displaying those in real times to the front end without doing HTTP requests to keep updating the logs. And yeah, really so much more. There's a lot of potential use cases for WebSockets. Now, why Socket.io specifically and not just traditional WebSockets? Well, Socket.io supports broadcasting, which WebSockets do not. It provides an API for event-based communication, which is quite powerful and easy to use. It has a fallback option. So if the client does not support WebSockets, it will fall back to HTTP long polling. Traditional WebSockets do not have that. And also, Socket.io supports proxies and load balancers. Those are not an issue when working with Socket.io. With WebSockets, that could quickly become a very big problem to deal with if you just deal with the plain WebSockets API. So this is just some of the benefits of why you should be using Socket.io instead of just plain WebSockets. So to get started with Socket.io, you would first need a node.js backend, and then on that node.js backend, you would be using Express.js, which is an HTTP request handler that you mount on a node.js HTTP server. And through Express.js, you also integrate Socket.io by installing it. We can see here a small code snippet. It's quite easy to set up. So you just create an HTTP server, you mount Socket.io on that server, and that is it. Then you listen for connection requests and do what it is you need to do with the WebSocket. So you might be saving references to them in memory. You might be, based on who has just connected, joining them on various rooms or channels or or topics, because Socket.io does have that that notion of messaging only to a subset of connected clients by means of rooms, for example. So think, for example, a chat room in an instant messaging application. Yeah, and finally, we just call the listen method on the HTTP server. So we actually start listening for HTTP and WebSocket requests. Express.js, because I mentioned it in my last slide. Well, it describes itself as a fast, unopinionated, and minimalist web framework. It does provide the ability to very easily write web handlers, and it integrates with various view engines that make it easy to render common content, so such as error pages. It offers the ability to add additional middleware at any point within the request handling pipeline. What that means is that you could be writing plain functions as request handler, and you could just be specifying them in a row, so in which order you want them, and your every HTTP request on a given route would go through each and every request handler that you have defined, and yeah, through that pipeline. And it's very quite easy to set up and work with it like that, and quite intuitive. And also it's very easy to integrate Express.js with Socket.io. On the client side, we use Angular for the front end for a variety of reasons. It's easy to separate UI from other code. I have other talks on this, so that means easy to separate. It is easy to implement separations of concerns because it provides dependency injection, pipes, root guards, and works with RxJS. So most things you will do and we will implement in Angular will be event driven, which is quite handy when integrated with Socket.io. And also you can code share between web and NativeScript mobile applications. I do have other talks related to that. So it can be quite handy. You just need to define different HTML templates for your web and mobile applications, and you can code share the actual TypeScript as long as you keep it separated from your actual UI manipulation. So something like a socket, like a service, an Angular service that's a wrapper over the Socket.io API. That's something that you could code share, that you could share between a web and a mobile application if you choose to use Angular for your project. Now, for Angular applications, there is a package on NPM available that is called ngx Socket.io. And this provides the ability to use observables for subscribing to Socket.io events, because the Socket.io API for JavaScript normally works with callbacks, and well, callbacks are manageable, but yeah, event-driven observables or even promises would be better than callbacks, and that is why I personally prefer to use the ngx Socket.io wrapper that's made specifically to work with Angular. To set up the ngx Socket.io module in your Angular applications. So first of all, what we're seeing here is your main application's root module. So that's typically called the app module. Here you define a set of UI components that you are declaring. You are importing some dependencies, which are either Angular modules that you have implemented as part of your project, or third-party modules that you have installed from NPM and imported into your project, like I'm doing here with the Socket.io module. and I just configure the Socket.io module to use HTTP localhost port 3000 because that is where my Socket.io server is running, as we've seen in the earlier code snippet. Right. Here we can see some basic code for a UI component. So this is obviously not UI code, but it is the code behind to which the UI code is bound. Here we can see we can quite easily just subscribe to message events from the connected WebSocket, and whenever we get a new message via WebSocket, we do something with it. In this case, we append it to a chat log. So yeah, this is for a messaging, an instant messaging application. Basically, whenever somebody sends a message, a WebSocket event is emitted to the Socket.io server, and then that further broadcasts it to all other connected clients. So we see we emit an event called message, and we also give it a payload with the username and the content of the message. And then finally, we just reset the current message to null. That has the effect of emptying the new message input in the UI. The HTML template for this would look like this. This is all there is to it. It's for this example, it is a text area bound to the log that we saw earlier in the code behind. So you can see the square bracket notation here actually means one-way binding in Angular. So whenever that log is updated, it will reflect in the UI automatically. Then we just have an input for a new message. We see here that we have what's called banana notation. So square and round bracket together, that means two-way binding. So whenever the user changes the value of that input in the UI, it updates the new message class member automatically. And whenever the new message class member is updated programmatically, it will reflect in the UI also. And finally, we have a button that will, when we click, will send a message, and we see that it's disabled if there is no new message to send. And we also bind to the click event of that button, which just calls the send message method that we saw in the earlier slide. Now, the result of the code you've just seen is this. So we can see that I specify the username as a query parameter. Angular is handling that, and we can see whenever somebody sends a message, we get, actually you can see in the developer console, we see messages coming in via WebSocket. So you can see I'm filtering out, I'm only seeing WebSocket messages here. So this is not an HTTP request, it's just messages coming from Socket.io and from the web client to Socket.io. Now, how do we integrate OpenEdge with all of this? Well, as you probably know, there is no WebSocket adapter for OpenEdge. So then Node.js now needs to become a middleware actually and communicate with OpenEdge using REST calls. So for that, we would need to set up a web handler in Express.js that will accept post requests from OpenEdge, and vice versa. If we want two-way communication, we also need a web handler in OpenEdge that will accept REST calls from the Node.js backend. So as far as clients will be concerned, they will only be communicating via WebSocket. However, Node.js will pass either all of those requests or some of those requests, depending on your requirements, to OpenEdge. And then once OpenEdge replies, it will broadcast a message further to connected clients. So then our architecture becomes more like this. So we have the connected clients connected via WebSocket, and then we have OpenEdge communicating with the Node.js middleware using HTTP. So REST interfaces in Node.js, what would that look like? Well, that looks like yeah. So now we see I've implemented a separate messaging service that can be used from can be reused from multiple locations within within my Node.js middleware. So I'm whenever I'm listening for new connections and whenever I receive a WebSocket connection, I register that socket with my messaging service. This is important because then my web handlers will also need to use this service that is aware of all connected clients. So this is not really difficult to achieve. We just initialize the messaging service so it's aware of what the Express app is, and then we tell it to listen for incoming connections. Now, next we're going to need to get into Express routers. Express routers are used to create modular route handlers, and they are a complete middleware and routing system. So they are also referred to as mini applications. So what that means is that I could be separating all of my main routes. Let's say I have a main endpoint for customers, another one for sales reps, another one for orders and whatnot. And each of them has multiple child routes. So I could be doing a get on /customers, getting a list of all customers. Then I could be drilling down by DID using a path parameter and so forth. Each of these could be split into separate routers. And then in my Express.js application, I could be mounting one individual, so one customer's router. I just mount it on the main /customers route, and then that handles all of the child routes. And that is quite useful to produce maintainable code in your Node.js web backend. So on the left, we see what multiple web handlers would look like without using a router. So we see we just define our web handlers on the main Express applications. So in this case, I'm defining two get web handlers, one for all customers and one for customers and find by ID by custom. Now, whereas if I just use a customer router, all of that goes into my customer router class, and then I just mount that customer router on the /customers main route. That makes it all much more maintainable. You can obviously do it you can do it like what we see on the left, but it's can quickly become a mess that way. So this is now this is what I call my broadcast router. Basically, I just listen for post requests, and whenever I get a post request on this route, I call the broadcast method on my messaging service, and then the messaging service takes care of broadcasting that message further to all connected web, mobile, and so forth clients. In the end, I just set a response status code of 204. That means no content, because I'm not actually returning anything to the OpenEdge backend. Then, as seen earlier, I mount the broadcast router on my main broadcast branch. So you notice how I say, okay, application use. When I say use and not get or post or what have you, that means listen on all HTTP verbs for main route /broadcast. And then mount the broadcast router, and then in my broadcast router, I just use / because that translates to, because I've mounted this router on /broadcast, the main, in the context of the router, the main root / is actually means / broadcast. Right, and now we can see this in action. I'm now sending HTTP post requests to my node.js middleware, and that is now broadcasting to the chat application in the browser. So just an HTTP post. Obviously, this can be replicated to send. You could send this request from OpenEdge, and then you'd be establishing effectively communication with your WebSocket enabled clients. So to glue it all together, this is what the register socket of my messaging service looks like. I just push the socket to, I save it to an array, and whenever I receive a message on that socket, because it's a chat application, I broadcast it further to all the other connected clients, because everyone is interested. It's a global chat room, and I also send that message to OpenEdge in case it needs to do something with it. For example, you might have a database table with all chat messages, timestamps, and so forth for chat history, and whatnot. The send to OpenEdge method looks like this. It is a basic HTTP request done with standard Node.js APIs. There's no third-party code in here. Yeah, just these are your request options: a host name, a path, method. Be sure to send to set the content type and content length headers. Those are quite important. Then just write the request body, which can be any kind of JSON that was sent from the web front end, and then finally end the request. And now for some OpenEdge code. To send an HTTP request to my Node.js middleware, we use the OpenEdge HTTP client. Basically, just construct a JSON object. In this case, this is for our prototype of the business entity designer for the web. So this is actually using a subject and then a JSON payload. So this is also setting the content type to application JSON, and yeah, finally it is executing the requests. Right, that's really all there is to it. And now I will show you both the messaging app and the business entity designer for the web I just mentioned in action. If you just give me 1 second, please. So this would be my messaging app. This is the web front end. So I just need to start it. And I also need to start my Node.js socket.io server. Okay, the web frontend has compiled successfully. Now let's see. Localhost 4200. Okay, so we have one window here. Now let's open another window. And this user is called Bob. So now I'm going to say something. Hello, send, and we see that it's already made it to the other window. And hello to you too. And both windows are now seeing the message. This is all handled, like I said, through the node.js middleware. You can see here already registered that it's registered some WebSockets. If I were to refresh this page, now it's registered so a new WebSocket with a different ID and so forth. And I've also promised you the sneak preview of our business entity designer for the web. That is still a work in progress, but when generating business entities, we are able to output the log of the backend process in real time to the front end. So 1 second, please. Just waiting for this to start. Oh, what is happening? Come on. I'm sorry, I really was expecting this to be faster. Okay. So let's see, business entity designer. Okay, so we have here our prototype of the business entity designer for the web. We can see here some database tables. I can add a customer table to the diagram. I can, yeah, let's also add a sales rep table, add a data relation between them. Let's see, okay. I can also open existing diagram files. So let's see, order business entity. And this has opened me a diagram file that is located on the backend. I can add now new temp tables and yeah, add a field and an index and whatnot. Let's see, entity properties. Let's change some text here. Okay, and okay, now let's see, let's validate the design. Ooh. Okay, no worries. And generate, create directory, yes. And we see we already have here a generating business entity code. That is a message that was received from the WebSocket, and now this is using our questions API, asking me if I am okay to overwrite this file. Let's hope I do have the rights to overwrite this file on the backend. And now it's generating code again. Yeah, okay, the file is write protected. But still, again, this is very much a work in progress. It's just that I don't have the rights to overwrite the file on the backend. However, let's see, WebSocket. I'm just going to refresh this page so we can see the messages coming via WebSocket. And generate, create direct. Oh, come on. Okay, so, well, yeah, so I still don't have the rights to overwrite that file, but we do see that the generating business entity code here has come as a WebSocket message from the node.js middleware, and in turn that was sent to it via HTTP request from our OpenEdge backend. Okay, and now it is question time.
And some people asked actually questions.
Okay.
So we have a question from Stefan Drissen, who asks, Tomcat implements WebSocket API since version 7, according to Google. So why is another moving part, in this case node.js, needed?
Tomcat implements WebSocket API, but can you use Socket.io with Tomcat and with OpenEdge also? So to my knowledge, that is not possible. And as I mentioned earlier, using the plain WebSocket API is much more difficult to maintain, implement, and adopt because of a lack of.
You would have, I mean, if you're talking Tomcat, you would have to implement the socket in Java.
Yeah, exactly.
In JavaScript. So that's a different thing, actually.
Yeah.
Okay, so we have another question from Roger. Can this be used to subscribe to a webhook and have it delivered to Parse-away?
Subscribe to a webhook and have it delivered to Parse-away? Yes. Yes.
Yes.
Most definitely, yes.
What you wanted to show.
Yeah, I did show that earlier, I think.
Okay, let's see if there was something in the chat. No, just a remark that the code sometimes a little bit fuzzy because of the compression.
The code on the screen.
Yes.
I apologize for that. I will make the code available via public GitHub repositories, and also I believe the slides will be available after the conference.
To dig deeper into this or want to have the demo code here, contact us from Consultingwerk. I'm pretty sure we can get that too.
Yes, of course, absolutely.
That's all of the remarks and questions. Yeah, thank you, Radu.
Okay, thank you all for attending. Hope you found it interesting, and thank you, Lutz, for your assistance here. Have a nice day, everyone. Have a nice day, everyone.
You too. Bye-bye.
Bye-bye.